The topic of this video is Anova, hypothesis tests, and the Anova table. A manager at LLD Records is investigating the company's market research techniques. She learns that much of the market research of college students is done during promotions on college campuses. She also learns that there are other methods of performing market research, for instance, over the phone, in the mail, etc. In all cases, for each new CD that LLD Records releases, the company solicits an intent to purchase score from the student, with 1 being the lowest score, no intent to purchase, and 100 being the highest score, full intent to purchase. The manager finds some information on a soon-to-be-released CD. The information details the intent to purchase scores from each of several groups of college students, with each group being questioned via a different method. Based on this information, the manager is able to perform a one-way independent sample Anova test of the hypothesis that the mean intent to purchase score for this CD is the same no matter the method of score collection. This test is summarized in the Anova table below. Fill in the missing entry in the Anova table and then answer the questions below. The table. Source of variation, degrees of freedom, sum of squares, mean square, and F-statistic are the titles for the 5 columns. First row, treatments between groups, has 4 degrees of freedom. Sum of squares is 434.19, mean square is 108.55, and F-statistic is not given. We need to find that ourselves. Next row, error within the groups. Degrees of freedom, 140. Sum of squares, 12,342.4. Mean square, 88.16. Final row of the table, total. Degrees of freedom, 144. Sum of squares, 12,776.59. First of all, let's complete the Anova table. Anova table has only one cell that doesn't have the information, and that cell is the F-statistic. To compute the F-statistic, it is enough to take mean square for treatment and divide that by mean square of error, and that gives me MSTR divided by MSE. MSTR is 108.55. MSE is 88.16. When I find the ratio of these two quantities, I get 1.23 as my F-statistic. Now let's get to first question that we need to answer below. How many intent to purchase scores were examined in all? Please notice nobody told us how many such scores we examined in the body of the story, but we need to find that information by using the degrees of freedom. And here's how we do that. Please recall that K represents the number of sampled populations, and K minus 1 represents the degrees of freedom for treatment. If 4 is equal to K minus 1, it tells me that 5 groups were examined, so K is 5. Next, the error degree of freedom is stated to be 140. We know again by definition that this degree of freedom is found by taking the total number of data entries n, uppercase N, subtracting with number of sampled populations k. So if n minus k results in 140, and we just figured out that k must be 5, which number minus 5 could give you 140? 145. That's my answer. Another way to look at the same problem, another logic of finding 145, is presented below. Please remember that the total degrees of freedom is found by simply adding these 2 degrees of freedom, and it gives me 144. Therefore, 144 is equal to taking k minus 1 degrees of freedom plus n minus k degrees of freedom. When you combine these variables, n minus 1 stays, k minus k becomes 0 or simply disappears. So it tells me that 144 is equal to n minus 1 if you add 1 to both sides, you get n equal to 145. Again, it's just another way of getting the same result. Second part of the question. For ANOVA test, it is assumed that the population variances of intent to purchase scores are the same no matter the method of score collection. What is an unbiased estimate of this common population variance based on the sample variances? According to the explanations you will read in ALEKS, unbiased estimate of a variance is represented by MSE, error mean square, which is 88.16. So simply choose this value to answer that question. The next part is asking to find p-value corresponding to the F-statistic for the Anova test and round your answer to at least 3 decimal places. Please remember that we work with F distribution that has right-tailed setup whenever we work with any hypothesis in this format. To find p-value means to find area to the right of the F-statistic 1.23. Please notice that I rounded F-statistic to 1.23 within the table, but I wanted to be as precise as I could be, at least to some reasonable level, and I used, instead of rounded to 2 places, I rounded to 4 decimal places my F-statistic, which comes from this ratio of MSTR and MSE, of course. I am looking for the area starting with this lower endpoint up to positive infinity with 4 and 140 degrees of freedom. This function on the calculator produces 301 thousandths. Because 301 thousandths is greater than 5% significance level, we do not have evidence against null hypothesis and we do not reject it. What does it mean? Based on this ANOVA, we're asked, can we conclude that there are differences in the mean intent to purchase scores for this CD among the different methods of collection? Well, my answer is no. And the reason is because by not rejecting null hypothesis, I claim that there is no difference between the means. Therefore, I conclude that there are no differences by saying no to this question.